Okay, we have looked at two techniques in inferential statistics. We've looked at confidence intervals and hypothesis testing. We are now going to look at how to analyze the results of an experimental study, and then in the next chapter we're going to learn how to analyze the results of a correlation study. So this is the hypothesis test for the difference between two means, and these are going to be tests that have two large independent samples, and by large I mean n greater than or equal to 30. And so let me just I'll explain what the independent means here in a minute, but let me just give you the example. It says here that there's a study here that wants to know, does studying affect grades? And so what they do is they get two experimental groups, and for one group they split students up between the two groups. For one group they study 2 hours per week, and for this other group they study 8 hours a week. And then they try to keep everything the same between the two groups, anything that would affect their grade point average. So the teacher, the textbooks, schedules, whatever could affect their grade point average, they keep the same between the groups, except for the number of hours that they work. And then at the end of the study, what they need to do is they need to compare the grade point averages. And so these are like two means. These are two sample means. And what you're wanting to see is if there's a significant difference between the two means. Okay, so what I mean by independent samples is that the students were just randomly divided between the two groups, and there's no connection between them. These are two independent samples. So a dependent sample would be like a before and after study. Like maybe the same group of students, for the first semester they study 2 hours a week, and then the second semester they study 8 hours a week. And then there would be a natural connection between the two samples. And that's a different sort of study. So this is an independent sample, an experimental study where you randomly divide people between the groups. Okay, and then what we're going to do is we're going to let mu here be what the true average would be for each of these two groups. Okay, so mu here would be all those students that study 2 hours a week. This is what their average, the true grade point average would be. And then for all those who studied 8 hours a week, this is what their true grade point average would be. And of course, in a sense, this is kind of hypothetical, because most students maybe some weeks study 2 hours a week, some study 8 hours a week, or some will study 2 hours one week, and then the following week they'll study 8 hours, then maybe a week they don't study at all, and then a week before tests they study 15 hours. And so really these are kind of hypothetical if you had a group that studied 2 hours a week, and if you had a group that studied 8 hours a week. These would be their means, the true means. And so what I want to do is I want to test at alpha equals 0.05 whether studying more increased the true mean GPA. Okay, so this is the group that studied more, and so I want to see if this mean is greater than this mean. So I would put a greater than sign here. And my null hypothesis here for this test is going to be that there's no difference between these two means. And so I'll call this mu1 and mu2. So my null hypothesis is going to say mu1 is equal to mu2. And that means there's no difference between the means. And then the alternative hypothesis is going to be no, mu1 is, this is a less than sign, is less than mu2. And so this is going to be a left-tailed test. Now notice you have to be paying attention here, because I'm testing whether studying more increased the true mean GPA. So that would make you think it would be a right-tailed test. But because of the way the table is arranged, and that this is mu1 and this is mu2, then I want mu1 to be bigger than, I want mu2 to be bigger than mu1, which means I want mu1 to be less than mu2, making that a left-tailed test. Okay, so it's really kind of, if your information is arranged in the table and what you decide to be mu1, what you decide to be mu2, is going to affect whether it's a greater than or a less than sign. And in this case, it is a less than sign. So Now, in the next step, we're going to determine the rejection region. So this wants me to test at alpha equals 0.05. Now this turns out to be just like a regular hypothesis test. So this is a left-tailed test, so I'm going to shade the left tail. And my alpha is equal to 0.05. And I'm going to use, because it's greater than or equal to 30, I'm going to use the critical z value. So what I'm going to do is I'm going to go to a one-tailed alpha, 0.05, go all the way to the bottom, and my critical z value is 1.645. So this would be 1.645, and then it's going to be negative because it's a left-tailed test. And so this side will be the reject H0. So in other words, in a minute, my test statistic will have to be less than negative 1.645 before I reject H0 and conclude that the studying actually did improve the grades. So what is the test statistic? This is the main thing here that changes. So the test statistic, the formula for this is x bar 1 minus x bar 2 minus mu1 minus mu2. So this is like your sample difference, and this is the hypothesized difference. Okay? And then this is going to be over sigma sub 1 squared over n sub 1 plus sigma sub 2 squared over n sub 2, and all this will be underneath a radical, like that, underneath the square root sign. So what I'm going to do is, this is like group 1, so I'm going to put a little 1 subscript by each of these. And this is group 2, so I put a little 2 subscript by each of these. And these are the numbers that go into this formula. Okay? Now, what about this hypothesized difference? So this is the hypothesized difference. So the null hypothesis says mu1 is equal to mu2. So what it would mean is that the difference between them is 0. So for us, we're always going to have mu1 equal to mu2 for the null hypothesis. So this will always be 0. So when I plug these things in here, I would get 2.56 minus 3.24. So that's the sample difference minus the hypothesized difference. All of that divided by, now I'm going to use the sample mean in place of sigma. So all of that divided by 0.84 squared over 30 plus 0.73 squared over 32. Okay, so notice I'm squaring the standard deviations and dividing it by their n. And then I'm going to take the square root of that. And so to plug this into the calculator, it looks kind of scary, but it's not too bad. So I'm going to do the top first. That's the difference between the sample means. Minus 0 wouldn't change anything. And now I'm going to take that top part, and then I'm going to have a radical, and then in parentheses I'm going to put all this. And I don't need any more parentheses except for the ones that go over the whole thing. So it would be 0.84 squared divided by 30 plus 0.73 squared divided by 32. So it's a parentheses around that whole thing. And you're going to get the right answer because you want it to do the exponent first and then divide, then add, and then finally take the square root. So if you put the parenthesis around the whole thing, you'll actually get the right statistic. And it's negative 3.39. So that is the test statistic, and that does lie in the rejection region. So that means I'm going to reject H0. So reject H naught. And H naught was saying that there is no difference between the groups. And so that means there is enough evidence to conclude studying improved true mean GPA. So you have to have enough evidence to reject H naught in order to conclude kind of the result of the experiment that you would like to show. And in this case, that is that studying did improve the true mean GPA. Okay, so that is a test that you could use to analyze the results of an experimental study. Now, it doesn't have to be used for just an experimental study. You could use it just to see whether or not there's a difference between any two populations, like maybe between Iowa and California, and you want to know, is there a significant difference in GPAs or ACT scores or whatever. You could use the same test, but it is often used to analyze the results of an experimental study where you have two experimental groups, like this example here. So we'll try a couple more of these in the next two videos.